The second thing we cover in this unit is calculating compound interest. Now, looking at this anchor chart, you are probably under the impression that it's the exact same anchor chart that we did previously when we calculated simple interest. Well, that's because the word problems are exactly the same. The reason I did this is because we need to be able to compare simple and compound interest. And the easiest way to do that is to have you work the exact same problems, but finding the compound interest. And then we can look and compare the simple interest anchor chart to the compound interest anchor chart, rather than having you work a completely separate anchor chart in the process of comparing them. So we're going to start with the basics of the formula. The formula for calculating compound interest is A equals P times 1 plus R to the power of T. I have it written out this way because A represents the account balance. Yesterday, when we did the simple interest formula, I represented the interest earned. So when you ran this formula, the number you were given was just the amount of interest earned on the account. When we're running the compound interest formula, what you're going to get as your answer is the balance in the account, the total money, including principal and interest already added together. That's important to remember, and you'll see why here in a second. So again, we have P, which is principal. We know that's our principal when we see what symbol? Dollar amount. R is our rate. And we know we found the rate when we see what symbol? A percent sign. And T represents what? Time. And we know we found the time when we see years or months. Okay, quick little extras here. Our principal is what? The original amount. Very good. What's our rule for rate? It must always be a decimal. And to make it a decimal, what are we going to do? We're going to divide our rate by 100 before we ever plug it into our formula. What's our rule for time? It must always be in years. And what are we going to do if they give us months? We're going to divide the number of months by 12. Perfect. Okay, so let's start working this problem. It says Robert deposits $3,000 in State Bank of India for 3 years, which earn him a compound interest of 8%. What is the account balance after 1, 2, and 3 years? So we have our information of $3,000. Well, there's our dollar sign. What is this? P, R, or T? Okay, he invested for 3 years. Oh, I see years. That's our T, very good. And then it's earning him an interest rate of 8%. Well, there's my percent sign, so that is my rate. And we can write divide by 100 right here, just so we remember, hey, we need to do that before we plug it into our formula. So off to the side, yesterday you wrote interest earned. Now we're going to write account balance. Equals. First is our principal. What did we say our principal was? Right, it's this $3,000 here. So we have 3,000. Then we're going to open some parentheses. The 1 is standard, it's always there. Plus, what is my rate divided by 100? Yes, it's 0.08. And what is my time? In this case, it is 1 year. Okay, so let's put this in our calculator. Follow along closely. We're going to start by entering 3,000 for the $3,000. Then you're going to use this button here to open your parenthesis. Then we have the 1 plus our 0.08. And we're going to use this button to close our parenthesis. And now we need to create a superscript. That's what this is called, a superscript. We do that by pushing this caret button here. And now you've raised your cursor up, and in that box, we're just going to type the number 1. And then when you hit enter, we find that the account balance after 1 year is $3,240. Again, it needs to be written as a sentence because we need to verbally acknowledge what this number represents. The balance after 1 year is $3,240. Okay, so let's do the same thing, only this time we're going to figure out what the balance is after 2 years. Again, we're going to write account balance. We're going to write our principal times 1 plus our rate, 0.08. Close your parentheses. And this time our superscript is what? It's 2, correct. So again, we're going to plug this into our calculator. $3,000. Open your parentheses. 1 plus 0.08. Close the parentheses. Again, we're going to use this caret to create our superscript. And then enter the number 2 and hit enter. Okay, so this says that the balance is $3,499.20. Our sentence can be the balance after 2 years is $3,499.20. Okay, and we can run this problem one more time for 3 years. And this time, our superscript will be the number 3. Again, we'll plug it into the calculator, 3,000, open parentheses, 1 plus 0.08, close parentheses. Use the caret for your superscript, enter the number 3, and hit enter. What would be a good sentence for this answer? The balance after 3 years is $3,779.14. I got 14 cents because I used this 6 to round up the 3 in the place value and the hundredths place value. All right, excellent. So now, just like yesterday, in some cases, there's going to be 2 pieces to solving the problem. When we ran our formula yesterday, we were finding the interest earned, and if we wanted the account balance, we had to add the interest to the principal. On this one, when we run the formula, we're finding the account balance, so the total amount of money in the account. If we want to find the interest earned, we're going to have to subtract the account balance from the principal to get our interest earned. So, in this problem, for the 1 year, the account balance after 1 year is $3,240. We're going to subtract the principal. What's our principal amount on this problem? Correct, it says $3,000. And again, we need to write this in a sentence. The interest earned in 1 year is $240. We'll run the same process for the 2 years. What's the account balance after 2 years? $3,499.20. What was the principal? That $3,000. when we subtract, so what would a good sentence be? Good. The interest earned in 2 years is $499.20. Okay, lastly, let's do the same thing for our 3 years to discover how much interest was earned after 3 years. What was the account balance after 3 years? Okay, and we're going to subtract the principal. What was the principal amount he invested in the account? Right. So after 3 years, what's a good sentence to represent this answer that we just found? Okay, the interest earned in 3 years is $779.14. So let's take a minute to look at the results of running these two formulas. So here I have my compound interest. Here I have my simple interest. Let's start with looking at the year 1. Okay, so in year 1, the interest earned using simple interest is $240. Down here, the interest earned when we're looking at compound interest is also $240. Meaning that at the end of 1 year, our account balance is going to be the same, whether it's calculated with compound interest or calculated with simple interest. The change happens after that 1 year period. So here, at 2 years, the interest earned after 2 years on a simple interest problem, or the account earning simple interest, is $480. The interest earned on the account accruing compound interest is $499.20. So your balance difference between the compound interest and the simple interest at the end of 2 years is a difference of $19.20. Which doesn't seem like a lot, but if that's your difference after 2 years, it would stand to reason that the difference is just going to continue getting larger. So here, looking at the amount of interest earned after 3 years on an account earning simple interest, you have $720. And on your account earning compound interest, you earned $779.14. So when you earn simple interest, you're just earning interest on the original principal that you invested into the account. The difference is when you're calculating an account with compound interest, you're not earning interest just on the original amount that you put in the account. You're actually earning interest on the amount that was in the account at the end of the year. So you're earning interest not only on the money that you put into the account, but also on the money that you have earned just by leaving it there. So when you are looking for a savings account, you want a savings account that's going to collect compound interest. When you're looking at paying back loans or paying back a credit card, you want that to be simple interest because you only want to have to pay back the interest on the purchase that you made, not the purchase you made plus all the interest that you've collected over time. Compound interest is going to help you save more money quickly than simple interest is, because you're not just earning money on what you put in the account, you're earning money on what that account has already accrued in interest. I'd like for you to work these problems here at the bottom of this compound interest page, and take the time here in the space at the bottom. I'd like you to compare what your results of compound interest equation are. Sorry, the compound interest formula are, and compare it to what the results of an account collecting simple interest with the same criteria is.